Hey everybody, this is Mr. Regner, and this is our Unit 4 review in video form. So I want to let you know right off the top of the bat, there's going to be a lot of questions here. We're going to go through our Unit 4 study guide that you've received in class. So with that being said, it's a good idea for you to work alongside the video instead of just watching it as a passive viewer. You could watch it as an active viewer and actually do the work along with me. Remember, you can pause the video, you can watch the video multiple times, fast forward to the parts that you need to see to use this video the best way possible that's going to help you individually prepare for our Unit 4 test. With all that being said, here's our Unit 4 study guide. So the first four, I think we can look at these together as a group because in all of them, it's a matching game here. We have options over here, and we want to match up the correct options with the correct answers on either side. So as we look at this, we have word sentences. Number one says a number n increased by 3 is 12. So I see some key words here like increased and is. Is, of course, means equals. So I'm going to write that out. I have n increased by 3. That's n plus 3 equals 12. N increased by 3 is 12. If I look over here, I see n plus 3 equals 12 is letter C, so I know it's letter C. Number 2 says triple a number is 12. Again, I see the word is, that means equals, so I know it's going to equal 12. So now I think triple a number. Well, a number is going to be represented by a variable. I don't know what that number is. And triple means 3 times that number. So if I just call a number n, that's 3 times n equals 12. And looking over here, I see that's option D. So I'll go ahead and put that in there. Number 3, a number n decreased by 3 is 12. So I see decreased, I see the word is, so I know it's going to equal 12. So it's a number n decreased by 3. N decreased by 3, that's n minus 3. And as I look up here, I see n minus 3 is option B. And finally, number 4, 12 is 3 less than a number n. So 12 is, and then less than is another key word. So I really have 12 equals 3 less than n, that's n, and 3 less than n, so n minus 3. Looking here, I see that's option B. So again, I might be a little bit tricked or confused here because I have two B's, but it does say right in the directions that choices may be used once, more than once, or not at all. So I'm good with numbers 1 through 4. Again, study those key words to help yourself out. Let's move on now to number 5. Number 5 says in the equation x plus y equals 9, what is the value of x if y equals 5? So if y equals 5, I'm just going to substitute. So instead of x plus y equals 9, I'm going to have x plus 5 equals 9. So I'm going to show my substitution step, and I haven't done any math here. I've just substituted in what they told me. So now I know that x plus 5 equals 9. I can subtract 5 or do the inverse operation on both sides. That leaves me with x on the left side, and then 9 minus 5 is 4 on the right side. And just to double check this, so I can do my check step, okay, I can take my x value of 4 plus my y value of 5 equals 9, and I can prove that 9 equals 9. So yep, that is a check. That checks out and it works. Let's take a look at number 6. What value of y makes the equation true? So I have y plus 4 and 2/10 equals 13. Well, for this one, I'm trying to figure out what y is, so I want to get y alone. I want to isolate my variable, and I do that by using the inverse operation. So I'm just going to show my minus 4 and 2/10 on both sides of my equal sign. Remember, if it helps, draw a little roadway here, separating your left and right sides. On this side, my left side, the 4.2 cancels out. I'm left with just y. So y equals 13 minus 4 and 2/10. Now, if I don't know what that is, I can just do the math. 13 minus 4 and 2/10. Notice here that I've lined up decimals. So in the case of 13, I had to add a decimal and a 0. So 0 minus 2, I'm going to have to borrow here from the 2, or from the 3 to make it a 2. That becomes a 10. 10 minus 2 is 8. 2 minus 4 I can't do, so that's really 12 minus 4, which is 8. So that's 8 and 8/10. So just to do my check, okay, so I can take 8 and 8/10 plus 4 and 2/10. That should equal 13. So let me add it up. 8 plus 2 is 10. Okay, that's where my decimal would be. 8 plus 4 is 12, plus the one that I carried over is 13. So indeed, 13 is equal to 13. It checks out. That one works. Let me move on now to number 7. Now number 7, I kind of like this one because it tells us we're looking at all 4 of these options and we want to know which one is a solution for 1/4 equaling n. So wherever I see n, I just take that out and put in 1/4. So I'm going to do option A here. I'm going to take out my n and substitute. So I have 1/4 minus 1 equals 3/4. Now, I can probably just look at this and use common sense here. If I have 1/4 and I take 1 whole away from 1/4, I'm going to get a negative number, or a number that's smaller than 1/4. I'm not going to be left with 3/4. All right, so even to do this, it kind of seems a little silly, but I guess I could do it anyway. I actually end up with a negative 3/4 equals 3/4. That's just not true. So I say no to A. Here's letter B. And I like kind of setting things up like this so I can show all my work and it guarantees that I'm right. So I have 16n, which I know means times. So I'm going to write my multiplication sign. Times 1/4 equals 4. Now it's already as small as it can get on the right side. So I want to then simplify on the left side. So I have 16, which I can make a whole number 16 over 1. So that's really 16 over 4. And then I could divide, and 4 goes into 16 4 whole times. So 4 does equal 4. So letter B is correct. Just to be sure, though, always a good idea to make sure. We can do all of them here. So I have 20 over 1 times 1/4, because that's what 20n is really saying if n equals 1/4. Okay, so this is going to be 20 over 4, and that's still going to be 15. 4 goes into 20 5 times, but 5 is not equal to 15. And my last one here in my little check, I have 3/4 plus n, which I know is 1/4, equals 1 and 1/4. Well, 3/4 plus 1/4 is 4/4, which does not equal 1 and 1/4. It actually equals 1. So that can't be right either. So my option there is B is correct, and I know that because I went through and checked all of them. Does that seem like a lot of work? Maybe, but it proves that I'm right, and I have no doubts that I got number 7 correct. Let's take a look at number 8. What is the solution of the equation C plus 8 and 57/100 equals 16 and 43 thousandths? Okay, well here I'm just going to use my inverse operation to get my C, or my variable, alone. And I do that because I'm adding, I'm going to subtract. Okay, by subtracting, that gets my C alone, and I have to do that on both sides of the equation. Remember, this is like a little roadway separating left and right. So here those cancel out. I have C equals, and I have 16 and 43 thousandths minus 8 and 57/100. I don't know what that is off the top of my head, so I'm going to do some math off to the side. Making sure I write down the correct numbers is always helpful. And notice I had to add an extra 0 here just to line up my decimals. So 3 minus 0 is 3. 4 minus 7, I'm going to have to borrow all the way over here. That's a 5. This becomes a 10, but then I reduce that to 9. And this becomes a 14. 14 minus 7 is 7. 9 minus 5 is 4. Drop my decimal down into my difference. And then I have 15 minus 8. That's going to give me 7. So I have 7 and 473 thousandths. I can, of course, do my check step here. So I'm going to take out my C and replace it with 7 and 473 thousandths. So that's 7.473 plus 8.57 equals 16.043. This is good. I'm starting to run out of ink, which I hope will not affect my video. So I have 7, and I'm going to add that with 8. I'm going to do that over here maybe. Again, I'm going to add a 0, so I have 3 plus 0 is 3. 7 plus 7 is 14. 5 plus 4 plus 1 is 10. 7 plus 8 plus 1 is 16. So I have 16.043 or 43 thousandths, and that indeed is equal to 16 and 43 thousandths. So I've checked it. I know for sure I'm getting number 8 right on my test. All right, that's page 1 of our study guide. Let's keep it rolling now and move on to page number 2. So on page number 2, number 9, it says if y minus 8 equals 6, what is the value of 3 times y plus 2? Well, for this one, I know this is correct. So I'm going to solve for y here. That's my first step. Then I'm going to plug in here and substitute and solve my expression. All right, so here I have y minus 8 equals 6. I'm going to do the inverse operation and add 8 to both sides. So I'm left with just y on the right or left side, and then 6 plus 8 on the right side gives me 14. So over here I'm going to take this and plug it into my expression. So I have 3 times 14 plus 2. Well, 14 plus 2 is 16. So I have 3 times 16. If I don't know what that is, I can just take 3 times 16. So 3 times 6 gives me 18. And 3 times 1 is 3, plus 1 is 4. That's 48. So my answer is 48. I'm going to seek out a new pen right now and hope this one works a little bit better. And there we go. So 48 is my answer. Let me go over here now to number 10. Students at a school went on a trip. The given equation models the total cost of the trip, where x is the number of students who went on the trip. 32 times x equals 1,344. How many students went on the trip? So this one, although it may seem difficult because of the words, we know that x is the number of students who went on the trip. And we want to know how many students went on the trip. So we're really just solving for x. So I'm going to rewrite this. 32x equals 1,344. If I'm solving for x, I just use the inverse operation to get the x alone. So I'm going to divide by 32 on both sides. That cancels out. So x equals my answer here. I don't know what that is, so I'll go over here and do some math. So 32 doesn't go into 1, it doesn't go into 3, it does go into 4, or 134. So I just have to use my guess and check method. So I'm thinking of 30 and 30, 60, 90, 120. So probably 4 is a good guess. 5 might have me go over because 5 times 3 is 15. So I'm going to go with 4 just to check that out. So 32 times 4. So I guessed it, now I'm checking. 4 times 2 is 8. 4 times 3. Oh, had a lapse of memory there for a moment. I don't know what happened to me. That's 128. So I'm actually pretty good there. So I have 4. This is 128. I subtract. Of course, I have 4 minus 8. I can't do that. I borrow here. This becomes 2. That becomes 14. 14 minus 8 is 6. All right, so now bring down my 4. 32 goes into 64. I actually know that's 2 times. 2 times 32 is 64. Subtract, that's nothing. So 42 is my answer. And so that means there are 42 students. I want to make sure I include that label there. And just to be sure, if I wanted to double check my math here, I could take 42 times 32. So this is the check step, 42 times 32, and see what I get. I should get my answer of 1,344, but let's see. 2 times 2 is 4. 2 times 4 is 8. Add my placeholder 0. 3 times 2 is 6. 3 times 4 is 12. And now I add them together. So that's 0 plus 4 is 4. 8 plus 6 is 14. 2 plus 1 is 3. And 1 is 1. 1,344, 1,344. It checks out. My math is correct, so I know I got number 10 correct. All right, now let's take a look at number 11. Grayson can use the equation y equals 5x to calculate his pay, where y represents the amount of pay and x represents the number of hours worked. how many hours did Grayson work if he was paid $67.50? So I know Y represents the amount of pay, X represents the number of hours worked, and I'm trying to figure out how many hours he worked. So I have Y equals 5 times X. Now X is how many hours worked, so that's what I'm trying to figure out. Y is the amount of pay, and it tells me my amount of pay right there, $67.50. So I'm going to just take that out, the Y out, and replace it with my money amount. So now I have an equation that looks like something I can solve. It actually reminds me a little bit of our work on number 10, same exact principle. So in this case, I have to divide by 5 because that's the inverse operation, and I want to get X alone. So I'm going to divide by 5 on both sides. So I have $65.50 divided by 5. 5 goes into 6 one time, that's 5. I subtract and have 1. Bring down my 5. 5 goes into 15 3 times, that's 15. I subtract, I get 0. 5 goes into 5 one time, that's 5. I subtract and I get 0. And then 5 goes into 0 0 times. So my answer here is 13.10, or $13.10 is X. And again, I can check this right here by doing a check step. So I know that it was $65.50 equaling 5 times $13.10. So let me just do some quick multiplication to check this out. 5 times 0 is 0. 5 times 1 is 5. Decimal point's going to go there. 5 times 3 is 15. 5 times 1 is 5 plus 1 is 65. 50, which is my answer here. So 65.50 equals 65.50. I've checked it and it checks out. I did the math the right way. Let's go ahead and take a look now at number 12. Number 12, it says select all the equations that have n equals 6 as a solution. So we did something like this on the first page of our study guide. We're really going to have to substitute here for each letter and see how it works out. So I have 2 times n, which is really 2 times 6. So 2 times 6 equals 12. And indeed, 2 times 6 is 12. That checks out, so A is correct. Here's my work for letter B. It says 24 divided by n, which I know is 6, equals 3. Well, let's see. 6 goes into 24. 6, 12, 18, 24. 4 times. So, whoops, 4 does not equal 3, so it can't be letter B. How about letter C? It says 5 times n, which is 5 times 6, minus 1 equals 29. Let me do order of operations. So 5 times 6 is going to give me 30. And that's 30 minus 1, which is, 29. 29 equals 29. That's correct. So C is correct. Here's option D. N times 5. I should have wrote 6 times 5 equals 3. Well, 6 times 5 is 30. And 3 is not equal to 30, so it can't be letter D. Here's my work for letter E. So E says 6n, that's 6 times 6 equals 36. And indeed, 36 is true. That works out, so E is correct. And then finally we have letter F. It says 12 plus n, which is really 6, equals 20. Well, 12 plus 6 is going to give me 18. And 18 is not equal to 20. So my answers are A, C, and E, and I know that because I did the work for A, C, and E and showed that they are equal, whereas B, D, and F all show they are not equal. So there's my work on page number 2. Let me roll right along and take a look now at page number 3. Here we go. So page number 3 begins with a chart. It says Oscar recorded his walking pace in the table below. What equation best represents this relationship? So here I have H and M, right? So I have a number for H that corresponds to a number for M, and I actually have 2 pairs. So I can use both of these pairs, plug them into these equations, and see which ones work out. So I'm going to do the same thing I've done before by showing all of my work. So letter A, I'm going to start with, maybe I'll call this group 1 and this group 2. So this is going to be A1. And I'll do A2 later if this checks out. But if it doesn't work for 1, there's no point in checking 2. So m, which is going to be 8 7/75, equals h, which is 2 5/10 plus 6 25. So I'm going to add these two together to see if it equals 8.75. So maybe I'll do this off to the side here. 6.25 and 2.5. Add a 0 just as a placeholder, and I'm going to add these together. All right, so I have 5 plus 0 is 5. 2 plus 5 is 7. 6 plus 2 is 8. And look at that, it checks out. Okay, since that checks out, I'm going to go ahead and do A2 now and see if this checks out. So same exact equation, but now I'm using the second group of numbers. So m is 24 5/10 equals, let's see, that's 7 plus 6 25. All right, so I have 6 25 plus 7, right? So that's 25, and then 6 plus 7 is 13. 13, oh, I was so close. And I was really looking forward to that one. So that one doesn't check out. That means A doesn't work out. Let's try out B. So I have H, which is 2.5. Maybe I'll separate that a little more. Equals M, 8 7/75, minus 17 5/10. Okay. Boy, well, I'm just looking at this here for a second. And I know if I take 8 minus 17, I'm going to have a negative number. So right away, I know it can't equal 2.5. That's a positive number. So without even doing a whole lot of math there, I can see that one is not going to check out. Since it didn't work for group 1, there's no point in even trying group 2. I know B is out. All right, let me try letter C, and I'll do C1 here. So I have H equals 3 5/10 times M. So let's see, H is 2 5/10 equals 3 5/10 times M, which is 8 7/75. So I'll do this up here. 8 7/75 times 3.5. Notice I didn't even worry about lining up decimals here, just multiplying as usual. 5 times 5 is 25. 5 times 7, and by the way, this just struck me here. You can use a scrap sheet of paper, obviously, to work out any of this stuff. I'm trying to squeeze it in up here, and thinking about this on the video is probably a little bit hard to see, so I apologize. All right, so where was I here? Another good reason why you shouldn't stop right in mid-math. 5 times 7 is 35 plus 2 is 37. 5 times 8 is 40 plus 3 is 43. Add my placeholder 0 here. 3 times 5 is 15. That's a 1. 3 times 7 is 21 plus 1 is 22. That's a 2 now. 3 times 8 is 24 plus 2 is 26. So I have 5. 7 plus 5 gives me 12. Okay, 3 plus 1 is 4 plus 2 is 6. 6 plus 4 is 10. And 2 plus 1 is 3. Now I'll add in 1, 2, 3 places. 1, 2, 3 places. So that's 30.625 equals 2.5. Well, there's a lot of math there, but I've definitely proven that C is out because that's not even close. Okay, let me go ahead, and now by process of elimination, I'm feeling really good about letter D. But let me just do this just to be sure. So I have M equals 3.5 times H. So I have 8.75 equals 3.5 times 2.5. Let me do this math over here. So 5 times 5 is 25. 5 times 3 is 15 plus 2 is 17. Add my placeholder 0. 2 times 5 is 10. 2 times 3 is 6 plus 1 is 7. So I have 5, 7, 8, and 2 decimal points. That's 8.75 equals 8.75. And whew, I'm glad that checks out because I was feeling like it would. Let me just double check though and use number 2, my second group of numbers here. So I have M equals 24.5 equals 3.5 times 7. So let me do this over here. 3.5 times 7. 7 times 5 is 35. 7 times 3 is 21, plus 3, is 24. 1 decimal point, that's 24.5 equals 24.5. Hey, that checks out for both groups, 1 and 2. So I know that D is my answer. Again, a lot of work on this one, but all we were doing is taking the numbers from our chart and plugging it into our equations that we were given down here with our 2 different variables, each represented by the 2 variables in the chart. All right, let's move on now to number 14. There we go. Number 14, it says the rectangle shown has a length of 24 inches and a perimeter of p inches. Which equation could be used to find the width of the rectangle? All right, so the perimeter is p inches. I know that. If I'm doing this, I know that this is going to be 24. This has to also be 24 inches because it's the other side of the rectangle. And then I don't know what the width is. So the width I could just label as W, and I know this is going to be W as well. And if I'm doing the perimeter, that would be 24 plus 24 plus W because I add up all the sides. That's all going to equal my P. Okay? So if I then combine my like terms, I have 24 and 24 that are like terms, and I have W and W that are like terms. So 24 and 24 give me, why did I write a 2? 48. And then 2, or W plus W is really just 2W. So that's going to equal P. So looking over here, I have 48 plus 2W right off the bat. Feeling good about that one. But let me just check the others to see. So this one looks good as well, but I'm missing that other W. Okay, that would be only if this had 3 sides and it has 4 sides. This one, it looks like they're just including like one side here and one side there. They didn't include all 4. Same deal here. They included 1 here and then 2 of my W's, but they missed my 4th one. So it turns out letter A is indeed correct. And I know that because I did it before I even looked at the multiple choice options. Let's take a look at the bottom question here, number 15. It says, write and solve an equation to find the missing dimension of the figure. Area is 50 centimeters squared. The height is unknown, h, and the base is going to be 10 centimeters. So I know I'm going to use my formula here. Area equals base times height divided by 2. And if you're curious where I got that from, that's the area formula for a triangle. So it's something we should probably know. That way going into it, we can write this down. Then we just substitute the numbers we know from our problem. So area is 50. The base is 10. The height is unknown. And then we're dividing by 2. So this is really a 2-step equation. I have to get rid of 2 different things to isolate my variable, my h, and get it alone. So I'm going to start by multiplying by 2. That's going to get rid of this. So I have just 10h on one side here. And then 50 times 2 is 100. I don't even need to do the math because I can do that one in my head. Over here I have 100 equals 10h. I still have to get that h alone, so I will divide by 10 on both sides. 10 divided by 10 leaves me with just the h, and then 100 divided by 10 is 10. So the height is 10, but I have to put a label on there, so of course it's 10 centimeters. So again, I had to use that area formula first, and from there it was just plug it in and go. Moving right along, let's take a look now at number 16 from our study guide. So it says a rectangular room has an area of 55 1/4 square feet. The length of the room is 8 1/2 feet. What is the width of the room in feet? We don't know the width. So if it helps you, and I know I'm a great drawer, so you guys are going to be jealous of my drawing, but there it is. I know that the length of the room is 8 1/2 feet. The width of the room we'll call W. And then the area, which is the measurement of the inside, equals 55 1/4 feet squared. We always square area, so that makes sense. So I can do a drawing if that is necessary. Some of you will find you don't need a drawing and you don't want a drawing, so don't use a drawing. It's totally up to you. But I do know I need to find the answer to this by plugging it into my area formula for a rectangle or for a parallelogram, which is area equals base times height. So I know the area. Let me just plug that in. 55 1/4. I know the base, 8 1/2. And I don't know the width, so I'll just put that as W, or times W. So in order to find The width, I have to use the inverse operation. That means I'm dividing by 8.5 on both sides. This will cancel out, leaving me with just W, which is what I want. So here I have 55 1/4. I'm going to rewrite this over here. Divided by 8.5. So we've seen problems like this so many times in computation since Unit 1. So in order to do this, I have to first take my numbers and turn them into improper fractions. And I do that by working around the clock. I multiply and I add. Okay, so I have 4 times 55. Boy, I don't know that off the top of my head, but look at me doing math off to the side. So 4 times 5 is 20. 4 times 5 is still 20, plus 2 is 22. So that's 220 plus 1. That's 221 over 4 because my denominator stays the same. That's going to be divided by 8 times 2 is 16 plus 1 is 17. And the denominator stays the same. So now I'm going to, I had a special highlighter here somewhere. There we go. I'm going to keep, change, flip, or KCF. So I'm going to keep the first fraction the same. Change my sign to multiplication. And then flip or use the reciprocal of my second fraction. So now I really want to look at this and think about common factors. Do these have any common factors? Well, 2 and 4 seem obvious. 2 goes into both of them. 2 goes into 2 once, 2 goes into 4 twice. 17 and 221, though, might be one that we're not familiar with or as familiar with. So watch this. I can actually do math over here. I'm going to see if 17 goes into 221. So let's see, 17 goes into 22 once. That's 17. I subtract. 22 minus 17 is going to give me 5. Bring down my 1. Oops, that's a 1. And then does 17 go into 51? Let me think about this. Let's see. My guess is maybe 3 times. Okay, so 17 times 3. 7 times 3 is 21. 3 times 1 is 3 plus 2 is 5. It's 51. Amazing. So that's 0. So 17 goes into 221 13 times, which means 17 goes into 17 once. It goes into 221 13 times. And by doing that cross simplification, now I've made my life a little easier because this is 13 over 2 is my answer, but I can turn that back into an improper fraction by dividing. 2 goes into 13 6 times with 1 left over. That 1 becomes my numerator. The 2 that was my divisor becomes my denominator. So my answer is really 6.5. And my label, of course, is feet. So I did all this work over here to get my answer of 6.5 feet. Of course, I can plug that in and check just to make sure if I'm not really too certain if that's the right answer, and that would tell me if I am correct or not. Let's go ahead and take a look at number 17. Here we have an area of 42 feet squared. What is the width? Which is h of the polygon. So we use the same formula. Area equals base times height. I know the area is 42 square feet. I know the base is 6, and I don't know the height. All right, so I have to divide by 6, which I can do. This cancels out. I have h over here. 42 divided by 6. If I don't know that off the top of my head, I can do math. Turns out this is probably a basic fact that you should know. So me showing the division here probably seems a little bit silly, but I'm doing it anyway. This is 7. 7 times 6 is 42. That's 0. So my height is 7, and it would be feet. 7 feet is my answer. Again, it all starts with the area formula. We plug it in from there. Let's go ahead and take a look at number 18. Now, number 18, I just want to point out this symbol here is a variable. There it is again there. A variable could be any letter, and in this example, they're using a Greek letter, which we haven't seen a whole lot of, and so I don't want that to confuse anybody or throw anybody off. It's the same thing as writing an X or a Y or an A or a B. So if it helps you and you want to replace that or something, then go for it. You can replace it. All right, so it says garden B is 5 more than the length of garden A. Find the length of garden A. So this is 5 more than garden A. This is 25. So I have 25 minus 5, because this is 5 more. So garden A is 20 meters. There's my answer. Very simple. This one, I think a lot of people are going to be confused by because it's got a picture, various reasons. Maybe it's the variable. Don't let that stuff confuse you. It's a very, very basic question. You just have to read it, understand it, plug it in, and go. All right. By the way, that's the end of what will be part 1 of our test, and now we're on to what will be part 2. So as we look at the beginning of part 2, it begins on number 19. We have a chart again with a D and a T. Some of these are filled in for us for D, and some are filled in for T, and others are blank. We have to fill in the blank spaces. Okay, so the question here says, the total number of hours T that Melly has practiced her flute after D days is modeled by the equation T equals 6 times D. Complete the table to describe this relationship. You must show your work and complete the table to receive full credit. Well, that's no problem. I can do that. All right, so if I know that T equals 6 times D, I'm just plugging in the value of D to find what T is. So it says T equals 6 times D. That's 6 times 2. So T would equal 12. So I plug in 12. Easy. Over here it says T equals 6 times D, and now D is 6. So T would equal 36. Easy. Now maybe a little bit more complicated because now they give us the T. So T, or 42, equals 6 times D. Well, no worries. I can just use the inverse operation and divide by 6 each time. That cancels out. So I have D over here, and 42 divided by 6 equals 7. So I put 7 over here. Easy. Again, this one may seem difficult at first, especially if you're not preparing for it. But in all, you look at it, and hopefully now you see it's actually pretty easy. Now we're on to number 20. We've got a rectangular prism over here. I know it is because it's a 3D shape. So the area, or the volume formula, is length times width times height for a rectangular prism. It says Brianna fills the prism shown with 280.5 inches cubed of liquid. What is the height of the liquid in the prism? So we know our length, our width, but we don't know the height. I'm just going to put a little h there just for fun. So I'm going to plug in some numbers now. 280.5 equals my length and my width. So that's 4 1/4 times 8 times h. Now I want to get my h alone. So the first thing I can do is actually combine my like terms here, because I can multiply 4 1/4 times 8. So I'm going to do that right now. So I have, let's see, 4 1/4. I'm going to multiply and add just like I did before. So 4 times 4 is 16, plus 1 is 17 over 4 times what is really 8 over 1, because any whole number can be put over 1 as a fraction. So now I can cross simplify. 4 goes into 4 once, 4 goes into 8 twice. 2 times 17, let me think about that. 2 times 7 is 14. All right, so that's going to be a 4 in my ones place. 2 times 1 is 2, plus that 1 is 3. So I have 34 over 1, which is really 34, right? So now I have 280.5 equals 34 times h. I can get that h alone by dividing by 34 on both sides. That's going to mean my h is alone over here, and now I have 280.5 divided by 34. Okay, so same deal. 2 times 280 plus 1. 2 times 280. Seems like something easy I should know, but I don't. I'm going to do it off to the side. 2 times 8 is 16. 2 times 2 is 4, plus 1 is 5. Oh, that was easy. 560 plus that 1 is 561. Keep the denominator the same over 2. Divided by 34 over 1. Now, of course, I remember when I'm dividing, I can keep, change, flip, and that's exactly what I'm going to do now. So I have 561 over 2 times 1 over 34. So again, I have 34 and 561. I want to say that maybe those two things go into each other. Maybe. Let me do some quick division over here just to see. So I have 561, 34. Does 34 go into 561? I don't know. So let me just say I can do the math and figure it out. 6 minus 4 is 2. 5 minus 3 is 2. Bring down a 1. Does 34 go into 221? Well, if I had to guess, and this is only a guess, I might say maybe 6 times. But as I look at it, I actually don't think it's going to work out. All right, so I don't think that does work out. Let me just say it was worth a try, though. All right, so let me go over here now. I have 561, and then I'll have 2 times 34, which I can do in my head. It's going to be 68. So I, of course, have to divide now. 68 into 561. So 68 doesn't go into 56. Oh my goodness, this has got to be a big number. I'm going to guess 9 off the top of my head, and I'll check it. And again, this is where I would highly suggest other pieces of paper. But I'm going to use my space up here. So I have, and I think you can see it in the video. So I have 9 times 8 is 72. 9 times 6 is 54 plus 7. Let's see, that would be 61. Wow, my goodness, look at that. I was so close, but I'm actually I went over 612. Good thing I checked that. Let me try 68 times 8. And to do that, I could do the multiplication again, or I could just subtract 68 here. All right, so 2 minus 8 doesn't work. I could borrow this 1. That becomes a 0. That becomes a 12. 12 minus 8, that's going to give me 4. And then I have 60 minus 6, which is going to be 54. Oops. So that's 544. That actually works out. So I have 544. And then I'll subtract from there. I have to borrow from this 6. That becomes 5. That becomes 11. That's going to be 7. 5 minus 4 is 1. And so I have 17 remaining. That's 17 over 68. So my answer over here is 8 and 17 over 68, because I can't reduce that down any further. Unfortunately, I would love to be able to, but it doesn't look like I can. All right, let me move on now to number 21. Hopefully this is showing up in our video. All right, your bedroom ceiling is 20 feet high. It's 2/3 as high as the living room ceiling. Write and solve an equation to find the height, h, of the living room ceiling. All right, so I know that the ceiling is 20 feet high, and it's 2/3 as high as the living room ceiling. So 2/3 times the living room ceiling would be equal to 20 feet. So I can write that out as an equation. So 2/3 times the height of the living room, which is going to be just h. So 2/3 of the living room is going to be your bedroom ceiling height, 20. Okay, again, read the statement very, very carefully and make sense of that. That's similar to a focus question we had recently. So to do this, I'm just going to use my inverse operations and divide by 2/3. So over here, I'm going to change this to 20 over 1 divided by 2/3. I will use my rule for division, keep, change, flip. I should be used to this by now. So I have 20 over 1 times 3 over 2. Well, 2 goes into 2 once, and 2 goes into 20 10 times. So now I have 10 times 3, which is 30. 1 times 1, which is 1. And that's going to equal 30. So my height equals 30 feet. So the height of the living room is 30 feet high, which makes sense because the bedroom is 2/3 as high as the living room. Okay, if it were 1/3 as high, it would be 10 feet. All right, so we can plug that back in and double check our work. All right, moving right along. Next up, we've got a couple multiple choice questions thrown in here. So 22 and 23, we can kind of pair together. We have to read them carefully, think about what they're asking us to do, and then select the option that makes the most sense. So number 22, Lily babysits after school. She makes $12 an hour. The number of hours, h, that Lily babysits each week varies. Which equation shows her total, A, amount of money made? Okay, so if we're trying to find the amount of money, we want to know A equals. And it looks like all four have that set up that way. So the amount of money is going to be $12 an hour times the number of hours she works. So it wouldn't be 12 plus H. It wouldn't be 12 divided by H. It wouldn't be H divided by 12. It would be 12 times H. So letter D seems like the winner here. Not a lot of work I can show there. It's all kind of mentally done. So keep that in mind. Here's number 23. John and his friends spent Saturday driving go-karts. It costs $8 an hour to drive them, and he has M dollars to spend. Which equation shows the number of hours H that he can drive? So it's $8 an hour. He has M dollars to spend. So if you think about this, I've got a beeping in my background, and I apologize. That's going to hopefully stop momentarily. If we think about this, we know that it costs $8. He only has M dollars to spend, right? So that's the most he can spend. If he has this much, let's just pretend like it's $80. That's M dollars to spend. He would be able to take that amount divided by how much it costs per hour, and that would tell us how many hours he can drive. So the hours equals M divided by 8. Right off the bat, that seems like our winner. But let's just double check. The hours equals 8 times M. Well, that would mean like we're taking 8 multiplied by how much money he has. We're going to get a much bigger answer there. This one says M divided by H. In other words, we take the amount of money he had divided by the number of hours, and that's going to equal 8. That one doesn't make sense. Letter D, it says the hours equals M minus 8. In other words, the amount of money he has minus one $8 bill. That's not going to work either. So A, like our first instinct showed, is correct. And guys, I hate to say this, but we're on the last page. We're just flying through this. I'm sure this video is just going quickly for you. Let's take a look now at number 24. We have a chart here. And I want to point out to you that this chart just shows us the line here. It shows us the hours here, the miles here. And so this question is actually a question about distance. So it says a boat is traveling across the ocean. At what rate is the boat traveling? Write a formula, show your work, and use a proper label. So I know that distance equals rate times time. Okay, so back to it. I'm just going to take this first line here. It says 1 hour, and that's going to be between 25 and 75, which I know is 50. So I'm going to use those numbers. I'm going to use 1 hour and 50 miles. That's what that point really represents. So I'm going to plug this in. My distance is 1 mile. My rate is something I don't know. I'm going to leave that as R. My time, oops, I messed that up, sorry, oops. My distance is 50 miles. I knew I was looking right at it, and I wrote down 1 instead. All right, so my rate is R. My time is 1 hour. Okay, so I really have 1 R, and 1 R really could be represented as just R. So this one is actually pretty easy. My rate is 50. But the tough part maybe is getting that label, and it's, again, miles per hour. The rate is always represented by the distance over the time. So whatever our labels are for distance and time are going to be our labels for rate. So the rate is 50 miles per hour. It's important to use that. So again, it says, write a formula. I wrote my formula. Show your work. I kind of showed my work here, right? And then use a proper label. That's going to be a key to get that label right as well. So this chart, although maybe it seems like confusing, actually pretty easy because I was able to take my lowest number here, and I found out that 1 hour equals 50 miles. When I plugged that in, that gave me my answer really, really easily and quickly. All right, sadly, we've come to the end, our last one. And this is kind of a doozy. I'm just going to be upfront and honest with you. All right, so it says here, you leave your house and walk for a half hour at a speed of 4 miles per hour. Then you run for 15 minutes at a speed of 8 miles per hour. You are now halfway to town. Write and solve an equation to find the distance from your house to town. Okay, boy, a lot going on here. We want to know the distance of walking, because remember, you are walking. We're going to add that with the distance of running, okay? And then that's going to equal the half of the distance from your house to town. So that's going to equal like the total, or let's say we'll call it half of your distance. So we'll say that's going to be your distance times 2, right? Because that's only halfway, so we have to multiply that by 2. So let me think about the distance formula. Distance equals rate times time. So I'm going to have a rate times a time for your walking. We're going to add that with a rate times a time for running, and then that's going to equal the total distance. Maybe I should have put total. Total distance times 2. So let me plug this in. When I was walking, let me think here. I walk for a half an hour at a speed of 4 miles per hour. So my rate is 4 miles per hour. I multiply that by a time that relates to the rate. And the rate here says per hour. So if it's half of an hour, I can't say it's 30 minutes. I would instead say it's 1/2 of an hour. So I'm going to write 1/2. So 4 times 1/2. Let me think about my distance running. Then you run for 15 minutes at a speed of 8 miles per hour. So my rate is 8 miles per hour. My time is 15 minutes, but again, it has to relate to that rate label per hour. So think about what 15 minutes is as it relates to an hour. That would actually be 1/4 of an hour. So I'm going to write that as 1/4. That's going to equal my distance times 2. So now I can just do some math here. 4 times 1/2. I could think of that as 4 over 1 times 1/2, which is going to be 4 over 2, right? So that's 4 over 2. I could think of this as 8 times 1/4, or 8 over 1. That's going to be 8 over 4. And that's going to equal my distance times 2. Okay? And then over here I have 4 over 2. Well, let's see. 2 goes into 4 2 times. 4 goes into 8 2 times. That's going to equal my distance, which I then need to multiply by 2. So 2 plus 2 is 4. That's going to equal my distance. I need to multiply that by 2. So my total distance is really going to be multiplied by 2, and that's going to be 8 miles. Because again, I need that label on there for my distance, and we're talking about miles per hour, and miles ran, and miles walked. So I'm 8 miles away from town. And I'm just now realizing that the video may have cut some of that off. But I hope you've got it. That's our work here for unit number 4. I've already lost my paper. There it is. That's our unit 4 review. I hope it's been helpful for you. And remember, the best way to prepare is actually to do the work in the study guide, to study, prepare yourself. And remember, you can always check your answers for every one of these questions to make sure you are correct. Hope you do your best. Remember, use this video wisely. Help prepare for your test coming up.